All right, the theme of our winter meetings was farming through adversity, which we all know that there's a lot of adversity, particularly after last year with the excessive rain we had. The price of farm gate prices being received are at historical lows. Just so I get an idea of the audience here, how many of you are actively farming? Okay, quite a few. So I'm sure you are aware, unless you're in some sort of specialty market, you're aware of that it's not a real bright picture overall in the farming community right now. But I think what I've got to share with you today is some bright information. To start with, let's talk a little bit about what a healthy soil is. This is the number one thing from a healthy soil is drainage. Matt talked a little bit about soil particles and different types of soil, the base material, and how biology can fit it all together and make crumb structure and all the good things we're used to in a healthy soil. But unless we have drainage, that's not going to happen. Now, sometimes we can get drainage working with things from the top down. If we don't have a high water table, if the soil is just tight, biology can get us there. But if we have a high water table, it's going to require ditching or toweling to start. If we don't have that, if we can't drain away the extra liquid, well, then the only thing that we can really do profitably with that ground is plant in reeds, canary, and harvest biomass. Whether you can get a forage or bedding crop or whatever, or let it go back to nature. But we can't make money farming ground we can't drain. That's just kind of the bottom line. A healthy soil is going to be a moderate pH. Extremes on both ends of the spectrum are not going to give us a really healthy soil. And when we think of pH, we need to think of lime as a fertilizer, not just a pH adjuster. One of the issues I have with some recommendations and some lime applicators, they like to go out there and throw on 3 or 4 years at once. It's not a good idea. It's not a profitable way to do it. Because lime is a fertilizer. The carbonate portion of calcium carbonate gives you an energy charge. But it's only good for the year you apply it. It doesn't carry on as long as the calcium component of the pH adjustment carries on. So if you make more progress both in soil health and your financial bottom line by rationing it out and putting on moderate doses for a few years in a row instead of all at once. And now we get to maybe the most important part. A healthy soil is alive. It's kind of the theme of our meeting here today. And the life in the soil, not only does it influence everything else I'm going to talk about, it also influences the first two aspects up here on the slide deck. Soil life builds drainage. Again, we can't start with a high water table and expect life to exist that we're looking for. The life will exist, but not in the forms that build soil colloids. It also has a big impact on pH. And I can use a case in point is my own farm, the home farm that I live on over in central New York, near Utica. When I bought the place, or my dad actually purchased the property 13 years ago, the pH on that soil was running above 7.2, 7.3. And it was a naturally high pH soil. I don't think any lime had been applied to that farm in years. We were sitting on top of a limestone bedrock. Most of the farm we have anywhere from 6 feet, some places maybe 10 feet to 6 inches above limestone. Now the limestone at the surface is fairly porous limestone. We don't really have drainage problems on that farm, but the soil is not all deep and it's all the pH is naturally high or tends towards being high. Half a mile down the road is a quarry where they mine a lot of limestone products, ag lime, as well as gravel and various building products. What I was going to tell you is in about 10 years time period, we didn't apply any lime. We really didn't apply a whole lot of soil amendments other than on-farm generated manure. There's a combination of rotational grazing and organic row crops. It wasn't organic to begin with, although it was basically farmed organically. As in the last few years I actually became certified, just because I was leaving too much money on the table to not do it. The pH today is running in the low 6s. Now I can use that opportunity to put on some relatively cheap fertilizer and put on a little bit of lime and get the response that lime will give me. But that will all happen through biology. There was no macro inputs at all that changed that. No sulfur. Sulfur is probably running a little low, but I haven't been intentionally adding any sulfur. So the life in the soil does affect that. It creates a good structure. Now we have our parent materials. We have the sand, silt, and clay. We have what we have. We're not going to change that economically. If you're talking about garden scale agriculture, well then yeah, you can probably bring in a truckload of something and change what you have. But out on the broad acre spectrum, we're not changing that. But life does change soil structure. And a healthy soil is going to have growing carbon levels. One of the functions of a healthy soil is it should improve every year. Now let me give you a little bit of a qualifier to that. It should improve every reasonable year. Last year on my own farm, I don't think I made any progress. I don't think many of my customers made any progress. It was just too wet, too long. Biology suffered. Everything suffered under that load of water. But in a normal year, in a functional year, a healthy soil should be better at the end of the year than it was when it started. And that shouldn't make much difference what crop it has on it, although some crops are better than others. It'll have active carbon cycling. This is a big one. We don't often think about this, but well, let me ask you this one. Can anybody here tell me the #1 plant nutrient needed? Now I'm asking this question here a little different place in my presentation than what I did at my other meetings, because at my other meetings nobody got it right. I'm asking it here thinking maybe it'll tip you off. Oh yeah, you don't qualify. Pardon? Well, oxygen is important, but everywhere else, again, I'm tipping you off a little bit here where I'm asking the question. But everywhere else I got the answer nitrogen. Well, nitrogen is what everybody talks about, what farmers hear about all the time, nitrogen, nitrogen. Well, nitrogen is important, but by volume, by a huge percentage, probably more than 10 times nitrogen, it's carbon. Carbon is what plants grow with. And that carbon needs to be available for plant growth, and plants need to put the carbon into the soil as well. Now carbon dioxide is mostly what plants are taking in to build their structures. That's mostly coming from the atmosphere. And as we all know, carbon dioxide has gotten relatively high in the atmosphere, enough that it's causing some concern in many scientific communities. But the 350, 400 parts per million carbon dioxide in the atmosphere is not nearly enough to grow an optimal crop. If you measure carbon dioxide in a growing system a couple of feet off the ground in a good healthy cornfield, it will be up to 10 times as high as the atmosphere at large. And that's what crops need to function and grow. And at the same time, that carbon has got to come from somewhere, and it's got to be taken from the atmosphere and put back into the soil to keep it working. Now, one of the questions that's kind of been in the scientific community. It's been we're starting to hear a lot about the question being asked, but it's not being answered and defined very well. It's how does all this relate to farm profitability? Or maybe you might narrow it down even to field profitability, crop profitability, because there's a lot of overarching things as far as whole farm profitability. A team of researchers associated with the University of South Dakota, Claire LeCan and John Lundgren were the leaders. They put a study out. It was released back in the late fall. I think it was a 2-year-long trial or study that they were doing with some really interesting observations related to farm profitability. The criteria of the study is they sampled 72 cornfields in the upper Midwest. Half of these were identified as regenerative, meaning they used multi-species cover crops, minimum till or no-till, integrated livestock grazing, and or eliminated pesticide use. None of them planted any GMO seed. Some were certified organic, but most were not. And to get into this group, they had to use 3 out of the 4 criteria listed here. The 36 fields identified as conventional, they all used genetically modified seed and 1 or more forms of insecticide. Some of them were no-tillers, but they were not cover croppers. So this is what they were looking at. They had some interesting results. Insect pests averaged more than 10 times higher in the conventional insecticide-treated fields. Now the overall number of insects was quite a bit lower, but pest insects were higher. The average grain yield in the regenerative fields was 29% lower, but the profits were 78% higher. And what I found most intriguing about this is the overall study showed a correlation of profits with soil, particulate organic matter, rather than yield. This actually was true across all the fields. They weren't, this last point, it wasn't split between, okay, the regenerative fields had it, the conventional fields didn't. It was looking at all the fields together, and the particulate organic matter, which is a component of organic matter that is available to plants, is the soluble carbon component we're talking about. It's not organic matter by itself, the total organic matter. Total organic matter can be associated with water holding, nutrient reserves, and a lot of good things, but total organic matter doesn't have a lot to do with how the crop is performing on that field in any given year. But the available particulate organic matter is what counted in here in this correlation. Now to summarize the profit correlation a bit, the active biology is responsible for a significant difference in fertilizer needs. In some cases on these cornfields, there was no fertilizer applied to grow the crop of corn. It was a worked-in cover crop. Some of these farms I know were grazing off the cover crop, which I think may have entered into the profit correlation a little bit as well. Although the corn yields were lower, they were using a shorter season corn to allow more shoulder production. The shoulder production was valuable to them as well. And in a wet year or dry year, these fields had a yield advantage, even though they used less fertilizer due to the healthy soil texture. And there was no economically significant insect damage observed in any of the fields with active biology, as was measured by the particulate organic matter. There are several reasons for this, diversity of species being one of them. Having all these fields having been cover cropped, having year-round plants growing there ends up with a lot better diversity of species. Also, I know from other work that I've done that damaging insects are almost always related to inefficient use of nitrogen. And most of your insects in corn need to have higher levels of nitrate, nitrogen than what the plant can utilize in order to function as a food source. One of the interesting things here that BT corn has taught us, was kind of confirmed what many of us in the regenerative agriculture already knew before that, is that an insect's digestive system is not the same as ours. If it were, BT wouldn't work. It wouldn't be safe. But there are other proteins naturally occurring in corn plants that will do the same thing as BT, and we don't have to have the genetic modification to get there. It's a little bit off topic, but that explains why some of why this happened. So I found that to be a very interesting study in terms of it's the first one I've personally seen that really put some numbers to farm profitability or field profitability based on soil health. And they took it all the way through, and that was the correlation they found. Now there's another, I think, important point about a healthy soil for us living up here in the northern end of the country especially. This wasn't part of that study. This photo was taken off of my own farm over near Utica. The first year, so we purchased that property in the spring. That fall I went across with a dry product that I knew would stimulate soil biology as well as had some minerals. But I didn't get a good spread. It was a pelletized product but had a lot of fines in it. So we didn't get a uniform spread. The following spring, it was about this time of the year, probably a little earlier than this, we had a late snow after the ground had melted off, and I could see every pass of the spreader across the farm where I'd went with that product. It showed up in the snow melt. I wish since I'd gotten out there and actually measured the difference, seen if I could register a difference on a thermometer. I didn't actually do that. But this is a phenomenon that I've seen repeated several times with various biological products. There's a significant difference where the biology is robust in the temperature of the soil. So I think that can be a definite benefit in the North Country. Now here's a quote that come out of that study that I was talking about. I thought this was a little bit of a strong statement. It says, the only way to generate soil organic matter in cropland is through fostering biology, which inherently is driven by plant communities through sequestration of CO2 from the atmosphere. Now we talk about adding compost, manures, all sorts of other things, and the way they wrote this, that really doesn't even enter in. I think in the big picture this is probably true. There's probably no way of economically generating soil organic matter other than through fostering biology, sequestering more CO2 from the atmosphere. And as a subheading to this comment, it was the things you can do to accomplish this: eliminating tillage, implementing cover crops, and cycling plant residue through livestock enhances this process. So here are the four things that I think really hinders the process. We've got tillage. We all know about the destructive work that tillage does, and no-till is becoming a bigger and bigger focus in some areas. But herbicides are not necessarily a benign option. Keeping in mind that the #1 used herbicide in this country and around the world is also a patented antibiotic, and you might get some idea what it could be doing to soil biology. Misapplied fertilizer can be very hard on biology. Here we've got different, there's a wide variation in fertilizers. Some are beneficial to biology, others can be rather hard on biology. And then I think the biggest one of all is this bottom one: low biomass or low photosynthesis, maybe the combination of both. This is the flywheel that drives the system, and if you get this one right, you can mess up a few of the other three and still make progress. If you don't get the bottom one right, you can't make progress no matter how good a job you do with the rest. Tillage. So how do we reduce the impact of tillage? Well, to start with, reduce tillage. Till with a purpose. I'm not going to say you need to go 100% no-till. I think we're a little far north to that for that to work in every situation, every time. I will say reduce tillage, but not to the point of hurting the biomass and photosynthesis part, or then you're not doing yourself any good. Of course, in today's economic picture, we can't afford any sort of recreational tillage unless we're part of an antique tractor plow club. Then you can have your recreation, but don't do it as a business. One of the things about tillage, I really like the action of some of the newer tools in the marketplace, the European design speed discs, as opposed to our old style gang discs. The thing to think about tillage, whenever you're tilling, is to avoid plow pan layers, disc pan layers. And the way you do that is to always make sure that the weight of the tool is riding on a rear roller, tires, or something. A properly designed tillage tool does not need weight to get it in the ground. It should suck itself into the ground. If you need weight to get something in the ground, you're creating a compaction zone at the bottom of the tips at the working depth. A really good bad example of that is something like the Airway. Airway was that, probably none of you here know the history of the Airway like I do, but the Airway was a great tool when it was first designed.